Hello and welcome to the channel. The date is officially December 19th, 2025. At this very moment as we speak, a mysterious visitor from the deepest, darkest reaches of interstellar space is skimming the gravitational surface of our solar system. We are tracking the object known to the astronomical community as 3I Atlas. It is currently reaching its absolute closest approach to Earth, passing at a specific distance of approximately 1.8 astronomical units. That is roughly 270 million kilometers from where you are sitting right now. This is not just another rock in the sky. This is the third confirmed interstellar object in history to penetrate our system, following the famous Oumuamua and Borisov. But 3I Atlas is doing something the others did not. It is changing, and it is changing in ways that our current scientific models cannot fully explain. Today, we are going to perform a deep dive into the real-time data streaming in from the world's most powerful observatories. We are going to look at the raw numbers, the spectral shifts, and the trajectory anomalies that have astronomers across the globe glued to their monitors. Because what we are seeing tonight suggests that 3I Atlas is either a very strange comet or it is something else entirely. Before we pull up the telemetry, if you want to stay ahead of this rapidly developing story as we receive updates from NASA and the ESA throughout the night, make sure you hit that subscribe button. We are tracking this live. Let's look significantly closer at the data coming from the Gemini Observatory. Just 48 hours ago, 3I Atlas was a faint magnitude 18 smudge on the CCD sensors. We expected a standard cometary progression, a gradual brightening as it neared the sun, followed by a predictable fade. That is not what happened. Instead, the object's luminosity spiked. It didn't just brighten, it flared. But the real mystery isn't the brightness, it's the color. As it crossed the frost line, the object displayed a distinct, vibrant blue hue. Standard cometary physics tells us this is likely due to the sublimation of carbon monoxide or ionized nitrogen. We have seen this before. But then as it approached this 1.8 AU mark, the spectrum shifted. The blue gave way to a piercing green. Now, green comets are not unheard of. We know that diatomic carbon and cyanogen gas can glow green when bombarded by solar ultraviolet radiation. If the story ended there, we would classify this as a chemically rich but natural body. But the story does not end there. In the last 6 hours, visual data has begun to show a new, unprecedented shift. The green is being overtaken by a metallic golden tint. This contradicts what we previously thought about the chemical composition of the coma. There are very few natural processes that create a sustained golden reflection in a cometary tail. Sodium tails can appear yellow-orange, but the spectral signature we are seeing doesn't match a sodium flare. It looks almost solid. It looks like a reflection. This brings us to the high-energy data. While the optical telescopes were watching the color show, the Hubble Space Telescope and the Chandra X-ray Observatory were looking at the object in the high-frequency spectrum. Comets do emit X-rays. Usually this happens when the solar wind slams into the cloud of gas surrounding the nucleus, a process called charge exchange. We expected a soft, diffuse X-ray glow. What we got instead were sharp, rhythmic peaks. Here is the crucial detail. The X-ray emissions are pulsing. They are not random fluctuations caused by the turbulence of the solar wind. They have a structure. A NASA astronomer, in a report that was updated just minutes ago, noted this could be the result of interaction with the solar wind, but the amplitude of the signal suggests more exotic processes. When a scientist uses the word exotic, it is code for we don't know what this is yet. The amplitude, the strength of the signal is far higher than the density of the gas cloud should allow. If the gas is thin, the X-rays should be weak. But the gas is thin, and the X-rays are blindingly intense. So what does this actually mean? It implies that the interaction surface, the thing the solar wind is hitting, might not be a cloud of gas at all. It might be a solid surface, a surface that is highly conductive. If you have a metallic body rotating in the solar wind, you could theoretically generate the kind of sharp X-ray peaks we are seeing. This is where the science gets uncomfortable for some and thrilling for others. We are looking at an object that changed from blue to green and is now shimmering gold while pulsing with high-energy radiation. I want to pause here and ask you, what is your gut telling you? Is this just a volatile mix of exotic ices we haven't encountered before, or are we looking at something manufactured? Let me know in the comments below. Now, let's layer in the thermal data. We are receiving feeds from the infrared sensors. Usually a comet is a dirty snowball. It heats up, it cracks, it vents gas, the heating is uneven. You get jets of gas shooting out from the side facing the sun, causing the comet to tumble. We call this non-gravitational acceleration. We expect 3I Atlas to be tumbling wildly as it sublimates, but the light curve, the graph that shows how the object's brightness changes over time, is remarkably smooth. It is not tumbling chaotically, it is rotating, and it is rotating with a precision that is unnerving. The rotation period is locked, it is stable. If this were a crumbling ball of ice, the venting gases should be spinning it up or slowing it down unpredictably. Instead, 3I Atlas is maintaining a perfect rhythmic rotation, almost as if it is stabilized. This stability is what allows that golden glint to appear so consistent. If it were a chaotic tumble, the gold flash would be erratic. But it's not. It's a beacon. It pulses on, off. We also need to talk about the coating hypothesis. The shift to gold has led some researchers to speculate about the surface composition. If the object has been traveling through the interstellar medium for millions of years, it would be bombarded by cosmic rays, turning the surface dark and red like Oumuamua was. And indeed, on approach, it was dark. But as it warmed up, that dark crust seems to have shed or cleared. The underlying material is what is reflecting the sunlight. Now, is it fresh ice, or is it a material that is resistant to solar radiation? The NASA report mentions evaporation of gases, which explains the green. But the gold, that requires a different explanation. Some mineralogists suggest iron-rich silicates, or perhaps a high concentration of sulfur. But sulfur doesn't reflect like a mirror. The albedo, the reflectivity of this object, has skyrocketed in the last few hours. It is reflecting almost 80% of the light hitting it. For context, fresh snow reflects about 80%. Enceladus, the moon of Saturn, is one of the most reflective bodies we know. 3I Atlas is rivaling Enceladus, but Enceladus is ice. This object is hot. It is currently basking in the full intensity of the sun at 1.8 AU. Ice should be sublimating violently, creating a massive chaotic coma. But the coma is tight. It is controlled. It is almost aerodynamic. This brings us to the most unsettling part of the evening's observations, the shape. We haven't resolved the nucleus directly. It's too small and too far away, even for Hubble to see as more than a point of light. But we can infer the shape from the light curve. Oumuamua was a cigar or a pancake, highly elongated. 3I Atlas appears to be different. The light curve suggests symmetry. It suggests a shape that is not the random potato-like lump we see in asteroids. The data is hinting at something geometric. If you are finding this analysis valuable, please take a second to like this video. It helps the algorithm push this scientific data to more people who need to know what's happening in our sky tonight. As we watch 3I Atlas drift through the constellation of Hydra, visible now with binoculars if you are in the southern hemisphere, we are left with a picture that doesn't quite fit the puzzle pieces we have. We have a comet that doesn't tumble, a gas cloud that pulses with hard X-rays, and a dirty snowball that shines like polished gold. The standard model is straining to hold these facts together. The cognitive dissonance in the scientific community is palpable. You can hear it in the hesitation of the official statements. They are careful, they are conservative, but the data is screaming that this is unique. And this uniqueness is exactly what has reignited a controversy that has been simmering since 2017. Because if nature is struggling to explain 3I Atlas, there is another hypothesis that fits the data with disturbing elegance. It is a hypothesis that has been championed by one of the world's leading astrophysicists. And tonight, his predictions are looking less like science fiction and more like a checklist. As we move into the next segment of our investigation, we need to talk about the A word, artificial, because there is a list of anomalies associated with this object that is far too long to be a coincidence. And the man who wrote that list believes we are staring right at a piece of alien technology. As we established in our analysis of the optical and X-ray data, 3I Atlas is behaving in ways that defy the standard cometary model. The golden reflectivity, the stabilized rotation, the high energy pulsing, these are the what. Now we must turn our attention to the why. Let's look closer at the data points he highlights. The most striking of these is the trajectory. When astronomers trace the path of 3I Atlas backward, rewinding the clock through the decades it spent traversing the void, they find a spine-chilling coincidence. The vector of its arrival aligns precisely with the region of the sky where the famous WOW signal originated in 1977. For those who don't know, the WOW signal was a strong narrowband radio burst detected by the Big Ear radio telescope. It lasted 72 seconds and never repeated. It remains the strongest candidate for an extraterrestrial transmission we have ever found. Loeb asked the question we are all thinking: what if the signal was a ping, a handshake? And what if 3I Atlas is the response? The probability of a random rock falling into our system along that exact line of sight is infinitesimal. Loeb calculates it at 1 in a billion. If this is a comet, he writes, the probability of such coincidences is 1 in a billion. But if it's a probe, then its approach to Earth could have been a scan of our planet for signs of life or technology. This connects to the second major anomaly, the anti-tail. Most comets have a tail that points away from the sun, pushed by the solar wind. 3I Atlas has that, but it also has a spike of material pointing directly toward the sun. In cometary physics, this is usually an optical illusion caused by the viewing angle of the dust plane. We see it occasionally, but the geometry of 3I Atlas doesn't support the illusion theory. The anti-tail is too sharp, too defined. Loeb suggests an alternative. It's not a tail. It's a thruster or an exhaust plume from a propulsion system fighting against the solar gravity to maintain a specific orbit. If you are just joining us, we are discussing the possibility that the object currently 270 million kilometers from Earth is an extraterrestrial probe. If you want to keep up with this investigation, make sure you are subscribed. Building on this, we have to talk about the destination. 3I Atlas is not just passing Earth. It is threading the needle of our solar system to line up a rendezvous with Jupiter in March 2026. The precision required to enter the system, pass Earth at 1.8 AU, and then intercept Jupiter is staggering. Jupiter is a gravity well, a massive shield that protects the inner planets. But it is also a source of immense energy and radiation. A probe seeking to refuel or to use a massive gravitational slingshot to accelerate to the next star system would aim exactly for where 3I is going. Loeb argues that this is an ideal close approach. It is too perfect to be random chance. It looks like a flight plan, and then there are the signals. This is where the water gets murky. In the last 24 hours, social media platforms, including X, have been flooded with reports from amateur radio astronomers and independent observatories claiming to detect anomalous bursts in the radio range coming from the direction of the comet. These are short, sharp pulses. NASA has officially classified them as noise from solar activity. And to be fair, the sun is active right now. Solar flares can create radio interference. But here is the crucial detail. The bursts are periodic. Solar noise is random. These signals have a beat. They have a rhythm. Some independent analysts have pointed out that the modulation resembles a compressed data stream. Imagine a probe that has been silent for centuries, waking up as it nears a star, collecting terabytes of data about the third planet, us, and then blasting that data out in a high-density burst. That is what a signal in the noise would look like. So what does this actually mean? It means we have a convergence of evidence. We have the visual anomalies, the gold color, the stability. We have the trajectory anomalies, the WOW signal origin, the Jupiter intercept, and we have the electromagnetic anomalies, the X-ray pulses, the radio bursts. Any one of these could be explained away as a fluke of nature. But all of them together, that is the Loeb limit. That is the point where Occam's razor starts to cut the other way. Is it simpler to invent 5 different new natural theories to explain one object? Or is it simpler to admit that one single theory, artificial design, explains all 5? I want to ask you a question. If this is a probe, And if it is scanning us, what do you think it is seeing? Are we a threat, a curiosity, or just a biological sample? Leave your thoughts in the comments. The skepticism from the mainstream scientific community is healthy and necessary. We cannot jump to aliens every time we see a weird rock. But the natural explanations are becoming increasingly convoluted. They require us to believe that 3I Atlas is a unique type of comet made of unique materials following a unique path, emitting unique radiation all by accident. It is a statistical nightmare. And while the debate rages on about what the object is, the object itself is not waiting for us to decide. It is moving, and it is moving fast. But it's not just moving fast, it's moving wrong. This brings us to the most immediate and startling development of the night. While we have been debating the color and the origin, the James Webb Space Telescope has been tracking the position, and the position is off. The celestial mechanics of our solar system are like a clockwork mechanism. We know where gravity should pull an object. We can predict the path of a comet to within meters, but 3I Atlas is disobeying the laws of gravity. It has deviated, and it hasn't deviated by a microscopic amount. It has shifted its course by thousands of kilometers in a way that gravity alone cannot explain. This is the non-gravitational acceleration we saw with Oumuamua, but on a scale that is far more dramatic. If you are enjoying this deep dive, please hit the like button. It helps us continue this coverage. As we prepare to look at the James Webb data in the next chapter, keep this in mind. A rock falls where gravity tells it to fall. A machine goes where it wants to go. The deviation we are about to discuss might be the smoking gun that moves this from a hypothesis to a confirmation. The object has shifted, and it shifted right after its closest approach to Earth. Was it a maneuver? Was it a course correction? Or was it a reaction to something it found here? As we established in the previous chapter, the theoretical framework for 3I Atlas being an artificial object is built on a foundation of coincidences. But theories are just words until you have hard data to back them up. And that hard data has just arrived from the James Webb Space Telescope, JWST. While the world was debating the color and the origin, the JWST was doing what it does best, measuring position with pinpoint accuracy. And the numbers it has returned are sending shock waves through the Jet Propulsion Laboratory. What happened immediately after the peak of the close approach? The data is unambiguous. 3I Atlas deviated from its predicted trajectory. We are not talking about a few meters. We are talking about a shift of approximately 0.06 million kilometers. That's 60,000 kilometers. In the vastness of space, that might sound small, but in the world of orbital mechanics, it is a canyon. If you throw a ball, you know exactly where it will land. If the ball suddenly turns midair, you know something else is acting on it. Let's look closer at the data. The deviation occurred precisely as the object passed the point of nearest approach to Earth. This is the moment of maximum gravitational interaction. Yes, but our models account for that. We accounted for the Sun, for Jupiter, for Earth, even for the Moon. The math said the object should be at point A. The telescope sees it at point B. The difference is the delta V, the change in velocity. This contradicts what we previously thought about the object's passive nature. If this were simple outgassing, the rocket effect of ice turning to gas, we would see a correlation with the solar heating. The gas jets would push the comet away from the sun. But the vector of this deviation is not purely radial. It has a lateral component. It moves sideways relative to the sun. Nature doesn't usually do sideways. Nature does away. A lateral shift implies a controlled vector. It implies a maneuver. So what does this actually mean? Speculatively, if this were an artificial object, such a deviation could have been a braking maneuver or a course correction. Why correct the course right here? Because this is the optimal point for data injection. If you are a probe flying by a planet, you want to be as stable as possible during the scan, and then you adjust your trajectory to hit your next waypoint. The timing suggests that the scan phase is over and the transit phase has begun. This aligns with the capture theory. If the object was scanning Earth for biosignatures, the chemical fingerprints of life, like oxygen and methane, or listening to our radio leakage, it would need to orient its sensors. The deviation might be the result of the object reorienting itself back toward deep space or toward its next target. An ESA expert commenting on this data stated, "We are observing a visitor that may carry secrets of another star system or even a message." The movement we are seeing is consistent with a low-thrust, high-duration propulsion event. Low-thrust, high-duration. That sounds a lot like an ion engine or a light sail catching a laser beam we can't see. But the movement isn't the only activity. In Japan and Europe, astronomers are recording increased activity in the ultraviolet spectrum. The Subaru telescope in Hawaii and the VLT in Chile have both reported that the comet flickers in ultraviolet light. Now, comets flicker. Dust clouds are turbulent. But this flickering is fast. It's rapid fire. It's happening at frequencies of hertz, not minutes. Here is the crucial detail. The flickering is regular. It resembles a modulated signal. If you were to take a fiber optic cable and flash a light down it to send the internet to your house, that's modulation. We are seeing a UV source on the object brightening and dimming in a pattern that looks suspiciously like binary code. Is it evaporation? Maybe. A rotating vent could create a strobe effect, but a rotating vent would slow down as the gas runs out. This strobe is constant. If you want to stay updated on this potential signal, make sure you subscribe. We will be tracking the decoding efforts live. The combination of the trajectory shift and the UV flickering paints a picture of an active machine. It adjusted its path. It is pulsing with energy, and it is doing all of this while heading away from us. The threat of collision is zero. The object is safely receding, but the psychological impact is immeasurable. We are watching something that acts with intent. This brings us back to the why. Why 60,000 kilometers? Why that specific shift? When we plug the new trajectory into the simulation, we see where that 60,000 kilometer difference takes it. It doesn't just move it away from Earth. It fine-tunes the arrival time at the next major gravitational landmark. It puts 3I Atlas on a precise intercept course with the king of planets. The deviation wasn't an error, it was a correction. It was ensuring that the date with Jupiter is kept to the second. I want to ask you, do you think the government knows more than they are telling us? Is the noise classification just a cover? Let me know in the comments. As we watch the object fade from the naked eye, moving into the darkness, we have to consider the possibility that the visit was the primary mission and the departure is just the commute home. Or is the departure the start of the next phase? The object is not just leaving, it is heading to the largest gravity well in our system. And if Avi Loeb is right, what happens at Jupiter in 2026 might make tonight's events look like a firecracker compared to a supernova. If you are finding this analysis helpful, please like the video. Building on this, we need to look ahead. The object is leaving Earth, but it is not leaving the story. The next chapter of this saga will be written in the shadow of Jupiter. And the models predict that 3I Atlas will not just pass by. It will interact with the giant in a way that could fling it out of the galaxy entirely or bring it back. As we established in the last chapter, the trajectory deviation of 3I Atlas was not random. It was a precise adjustment that has placed the object on a collision course, not with a planet, but with a gravitational keyhole. The destination is Jupiter, and the date is March 2026. While the world is still reeling from the close approach to Earth, astronomers are already looking ahead to the main event. Because if Earth was the scan, Jupiter might be the engine. Let's look closer at the data regarding this future rendezvous. The object is currently speeding away from the Sun, losing kinetic energy as it climbs out of the solar gravity well, but in a few months, it will begin to fall toward Jupiter. The geometry of this encounter is what we call a gravity assist or a slingshot. We use this all the time. The Voyager probes, Cassini, New Horizons, they all stole momentum from Jupiter to fling themselves further out. But 3I Atlas is doing it differently. A natural object like a comet usually falls into a chaotic orbit when it gets too close to Jupiter. Jupiter is the comet eater. It captures them, rips them apart, or throws them into the Sun. 3I Atlas, however, is aiming for a specific altitude above Jupiter's cloud tops. It is aiming for the sweet spot, the exact corridor that maximizes the velocity boost without getting trapped in the radiation belts. This contradicts what we previously thought about random entry. The probability of an interstellar object entering the solar system, passing Earth at a scannable distance, and then hitting the perfect gravity assist vector at Jupiter is statistically vanishing. It is like throwing a dart from New York and hitting a bullseye in London after bouncing it off a wall in Paris. So what does this actually mean? If we follow the artificial hypothesis, the Jupiter flyby serves two potential purposes. The first is propulsion. By diving deep into Jupiter's gravity well, the object can gain a massive speed boost, enough to leave the solar system at a velocity that exceeds the galactic escape speed. It's the perfect exit strategy. The second purpose is far more intriguing. Jupiter is not alone. It is surrounded by a mini solar system of moons: Europa, Ganymede, Callisto, worlds with subsurface oceans, worlds that are prime candidates for life. If 3I Atlas is a probe, and if it scanned Earth for surface life, it would logically want to scan Europa for subsurface life. The trajectory takes it dangerously close to the orbit of the Galilean moons. Here's the crucial detail. The course correction we observed near Earth, that 60,000 kilometer shift, was exactly what was needed to align the probe with the plane of Jupiter's moons. Without that shift, it would have passed Jupiter at a high inclination, missing the moons entirely. With the shift, it threads the needle. It passes through the equatorial plane. It gets a front row seat to the water worlds. This is where the architect theory comes into play. Some astrobiologists have suggested that if you were to design a mission to the solar system, you would visit Earth and Jupiter. They are the two most important data points: Earth for the biology, Jupiter for the physics and the chemistry. 3I Atlas is visiting both in that order with a course correction in between. If you want to follow this mission all the way to Jupiter, make sure you are subscribed. We will be here in 2026. The interaction with Jupiter will also be a stress test. Jupiter has the strongest magnetic field in the planetary system. If 3I Atlas is electronic, if it has shielding, if it emits radio signals, Jupiter will light it up. The interaction between the object's magnetic field, if it has one, and Jupiter's magnetosphere could create auroras, radio bursts, and synchrotron radiation that will be visible from Earth. We might see the object turn on in a way we haven't seen yet. There is also the question of the return. NASA and astronomers confirm that the comet will not return as its speed exceeds the sun's escape velocity, and it is not gravitationally bound to our system. The current models show a hyperbolic trajectory, one way in, one way out. But this assumes the object is a rock. It assumes no engines. If 3I Atlas activates propulsion at the periapsis of the Jupiter flyby, at the closest point, it could maximize the Oberth effect. A small burn there yields a massive change in final velocity. It could use that energy to stop, to enter orbit, to stay, or as Loeb speculates, it could use that energy to transmit, to send a high-power beam back to where it came from, using the gravitational lens of the sun or the energy of the maneuver to power the signal. If this is a comet, the probability of such coincidences is 1 in a billion. But if it's a probe, then its approach to Earth could have been a scan, and Jupiter is the uplink. I want to ask you, if it sends a message back, do we want to know, or is ignorance bliss? Leave a comment below. The encounter in March 2026 will be the final exam. If it behaves like a rock, we will know. If it maneuvers again, if it adjusts its tilt to scan Europa, if it fires an engine, then the debate is over. We will know we are not alone. But for now, the object is drifting. It is moving from the warmth of the inner solar system to the cold, dark of the outer planets. It is fading from our view, but it is not fading from our attention. The data we have collected in these few short days, the gold color, the X-rays, the deviation, has already changed history. I want to leave you with one final thought. If you could send a message back with 3I Atlas, a single sentence to whoever sent it, what would you say? We are here. Come in peace or stay away. Leave your message in the comments. Thank you for watching this deep dive. If you found this analysis thought-provoking, please hit the like button to boost scientific content on this platform. Until next time, keep looking up.